Welcome. Lesson 66, solving inequalities by adding or subtracting. What do you need today? Pencil. Got this one here at the Oregon State Fair. Shh, don't tell Bethan. She kind of has a thing about OSU. No, yellow, orange. Sorry, orange. Go Beavers. Need that notebook to write stuff down you can use when you're taking a test. You better pay attention to that. Homework paper, print some of that off for yourself. I need this. I don't have very many of these right now, so I'm thinking there's not a lot of homework being done. You're going to need some glow paint for later when the sun goes down. Let's get warmed up, okay? Me. Oh, can't go that high. There we go. All right. Ready to do some math? There we go. Okay, for inequalities, we're going to be doing stuff on the number line. We're going to be drawing circles and arrows today. And the rules for all the do unto one side as thou must do unto the other manipulation are the same for inequalities as they were for equations. Equal sign, equation, inequality sign, greater than, less than, and we have same rules in the inequalities. For addition and subtraction, we get to multiplying and dividing, we have to take care of our negatives. There'll be a little rule for that, but not today. This is the easy stuff. Okay, so get ready here. I got my little teeter-totter, and this teeter-totter is definitely going to go this way because 7 is greater than 5. Now, if I add 2 to both sides, it is still true that 7 plus 2 is greater than 5 plus 2 because I've done the same thing to both sides, and 7 is still bigger than 5. We've added the same amount to both sides. We're going to treat the bits that are extra, we're going to treat stuff like x in there, and basically we've got a few of our inequality signs to take care of. What does that mean when we draw the picture? But this is true, and this is true as well. 7 take away 2 is still greater than 5 take away 2. That's still true. So let's put some x's in there, and let's deal with addition with inequalities, or at least when we would have to use addition to solve this type of problem. Same thing, got our teeter-totter here. It's going to tip this way. Oh, I got to turn that off. Hang on a sec. Hey, what are you doing that for? My apologies. That was embarrassing. Alrighty, so we want to get the x on one side of the teeter-totter all by itself. And then we're going to have to graph this thing. So addition here, now we have to add 10 to both sides. When we add 10 to both sides, we have x. We have x is less than, and x is less than 10 and negative 6, which is 4. So this is the end goal here of this thing, and then we need to do the picture. Okay, and so to graph. First thing that we need is a number line. I'm going to get rid of this thing right here. We're going to put in our number line and put some doodles on it. We need the number 4 on there. I'm going to put that right there. So that's 3, 2, 1, 0, and 5 this way. And then we have to plunk in the other stuff. What other stuff? Well, we need enough on there for an accurate answer. So let me go over this stuff again really quickly. We've got these various versions of inequalities. And if we put x on the left side, this basically tells us which way our arrow needs to go. Okay. The rest of it is just figuring out what do we do with the circle. Once we find that spot, do we fill it in or do we not? Well, this means that x is less than but not equal to. So we leave that arrow, or leave that circle open, and we put the arrow this way. Okay. This one here says that x is greater than something, and so we don't fill it in. It's not also equal to, and then we draw the arrow this way. This one says that it's less than or equal to, so because it could be equal to, we fill it in. We put our arrow going in that direction. And this one says that it's greater than or equal to, so we fill it in, and we make our arrow go that direction. Basically, that's it. I mean, that's how you identify. You look at those, one of those four, and you say, well, that's what I got to do with it. So this one says that x is less than 4. So we put our circle at 4. We do not fill it in, and we draw our arrow that way. The answer set is somewhere over there. So number line, gather information, and then third thing will be verify with the original inequality. The way that we do that is that we're going to pick some values near 4, and we're going to pick 4 as well. And we're going to just make sure that the original thing was true. Okay? So we got the fact here that x is less than 4. That makes this true. And anywhere over here would be an answer as well. 3, 2, 1, 0. 5 shouldn't be an answer. 4 shouldn't be an answer. So here we go. We take that original thing. X minus 10 is less than -6. And we're going to try this for x equals, let's start with 3. This should work, right? And basically all we're going to say is true or false. So 3 minus 10 less than -6. 3 minus 10 is -7. Is -7 less than -6? Yes. So that's true. That makes sense because there it is on the picture. Then how about, let's plug in a 1. 1 minus 10 less than -6. Well, yeah, that's -9. So that's true. That goes along with our picture. What if we picked the number 5? Well, it shouldn't work, should it? 5 minus 10 less than -6? No, -5 is greater than -6, so that's false. And then if we plug in 4, if this is true, then -6 is less than -6, and that can't be true. So that is false as well. That lines up with what our picture says, so we must be doing something right. Subtraction, same rule. If we ever have to use subtraction with like x plus 2 greater than 3, the x is on this side, so I'm going to have to subtract 2 from both sides, and it's still true. X is greater than 3 minus 2, which is 1. That is what we have to draw. We need a number line. Put a 1 in there somewhere. It is only greater than, but not equal to, so we draw just a circle and we don't fill it in. And then which way does our arrow go? Well, if x is over here, the arrow tells us, this thing tells us which way our arrow is supposed to go. It should go that way. And there's our answer. We don't fill that in because if we went back to our original equation and we plugged in 1, 1 plus 2 is not greater than 3, is equal to 3. We plug in 2, that's true. We plugged in 3, that's true. But if we plugged in 0, that's not true. And that makes sense because that would be over here. Honestly, that's it. This is a short one, I know, but every now and then it's nice to have one of those, isn't it? Yes, it is. All right, we'll be seeing you for lesson 67.